Today in the workshop we'll be using PlatformIO, an alternate IDE for the Arduino and many other microcontrollers. I'll show you how to install and use PlatformIO under Visual Studio Code. We'll also build a servo motor controller with an LCD display. We're exploring new environments today, so welcome to the workshop. Well, hello and welcome to the workshop. And today we're going to be programming microcontrollers, which of course is something we do quite often over here, except instead of using the Arduino IDE like we normally do, we're going to be using a different programming environment, something called PlatformIO. Now, PlatformIO itself is not an IDE. In fact, it is a plugin for other IDEs. It can also even be run at the command line. And we're going to be running it as a plugin for a very common IDE, something called Visual Studio Code. Now, from the name, you can probably guess that Visual Studio Code is a Microsoft product, but this is an open source product from Microsoft. Yes, Microsoft does indeed make open source products. And this is available not only for Windows, but for Linux and Mac OS X as well. So it's pretty well available anywhere that the Arduino IDE would be available. Now, why would we want to move from the Arduino IDE? After all, it's a very familiar environment, and it pretty well does the job. It has a code editor, it has a compiler, it has a serial monitor, it has a method of managing our different boards, and it also has a method of managing libraries. Well, PlatformIO does have all of those features, plus a number of other features that can help us write better code, that can help us find errors in our code as we are writing them, and can even help us solve those errors. And as you get more advanced with your coding and write longer code, or code that encompasses more than one file, you will really see a lot of advantages with PlatformIO over the Arduino IDE. So let's get started and take a look at some of the features of PlatformIO, as well as the difference between it and the Arduino IDE. PlatformIO is a cross-platform tool for C++ development on embedded devices like microcontrollers. It runs as a plugin in Visual Studio Code and in a number of other IDEs as well. PlatformIO is also available as a command line utility for those who don't require a graphical user interface. Because it runs under VS Code, the IDE has advanced features and includes a debugger. PlatformIO is much more capable than the Arduino IDE, but it does have a steeper learning curve. Today we're going to make several comparisons between the Arduino IDE and PlatformIO, but before we do, it's a good idea to review exactly what an IDE is. We'll begin by reviewing the process of taking data from a computer and loading it onto a microcontroller. We start by using some sort of an editor to write some code. This is human-readable code, and we're usually using a simple text editor to create this. After this, our code needs to be sent to a device called a compiler. The compiler takes a text file and produces machine-readable code, and this code is sent to the target microcontroller. An integrated development environment, or IDE, can have several features. It requires some form of a code editor to enter code. Many IDEs have syntax highlighters to make the code easier to read. Another nice feature is autocomplete. This lets you start typing in code and having the editor complete it for you. A debugger is a very handy device to use when your code doesn't work the way that you think it should. This is a more advanced feature, and not all IDEs contain a debugger. A compiler is an essential part of the IDE. As we just saw, the compiler takes the text file you've written and turns it into machine-readable code. When working with microcontrollers, it is essential that our IDE has an uploader. This component takes the compiled code and transfers it to the target device. A library manager is a very handy feature. It allows you to manage code libraries, additional pieces of code for working with specific devices. Version control is also a very advanced feature. This allows you to maintain records of different versions of your code and revert to them if necessary. When working with microcontrollers, a serial monitor is a very handy feature to have. Another handy feature when working with microcontrollers is a board manager. This allows you to work with several different types of microcontrollers instead of just one. Now, the Arduino IDE has many of these functions built in. PlatformIO has all of these functions. We're going to be running PlatformIO as a Visual Studio Code plugin, which is the most common method of running it. Microsoft Visual Studio Code, or VS Code, is an open source product. It's available for all major platforms, Linux, Windows, and Mac OS X. We'll also require Python 3.5 or higher to use PlatformIO. In order to get started, our first step would be to install Visual Studio Code on our operating system, and then install the PlatformIO plugin. So let's move on and do exactly that. So the first step in getting PlatformIO is to install Visual Studio Code. You're also going to need a Python environment that is at least Python 3.5 in order to run PlatformIO. So what we're going to do right now is we're going to install Visual Studio Code and Python under Linux, under Mac OS X, and under Windows. And after that, I will show you how you can install the PlatformIO extension under Visual Studio Code. So let's get started. There are a couple of different methods you can employ in order to install Visual Studio Code under Linux. One of the methods was one that I illustrated a couple of weeks ago in the video that I did on building a Linux workstation, and you'll find it at the 52-minute and 2-second point of that video. With that method, I used the Snap Store and installed a Snap package. Since that runs in a virtual environment, I also had to install a Python virtual environment. Another method that doesn't require the virtual environment is to install it directly from the installation files available on the Visual Studio Code website. You will need to find out first, though, if your version of Python is at least version 3.5. So go to your command prompt on the terminal and type in Python 3 / version. If the version that comes back is over 3.5, then you can just go ahead and use the installation file from the website. Download the appropriate installation file for your build of Linux. If it's Ubuntu or Debian, you'll want to install the deb file. Once the file has been downloaded, you can open it, and this will invoke the installer if you're using Ubuntu. Just click the Install button and authenticate with your password. And that's basically it. The installation program will install Visual Studio on your Linux machine. Once the installation is complete, you can open Visual Studio Code. The installation of Visual Studio Code on Mac OS X is extremely simple. You begin by going to the Visual Studio web page and downloading the latest version of Visual Studio for the Mac. Once it's been downloaded, you can go into your Downloads folder and you should see the Visual Studio Code file. You can actually run it directly from there, although it's probably smarter to drag it into your Applications folder. The first time you run it, you're going to have to allow it to run, as it's a file that's been downloaded from the internet. And that completes the installation of Visual Studio Code. However, in order to install PlatformIO, we are also going to need to upgrade our version of Python. In order to install Python, we'll need to go to the Python webpage at python.org and download the latest version of Python for the Mac OS X. Once we've downloaded that, we can go and open the package that we've downloaded. You'll have to hit Continue a number of times on the installation screen, and you'll need to accept the license agreement. You'll also need to provide your password before you install the software. Once Python has been installed, you can close the installation utility. You also have the option to move the install files to the trash, and I recommend you do that. In order to verify your installation, open the terminal and use the same command we used in Linux, Python 3 -- version. As long as the version is higher than 3.5, then you're ready to install PlatformIO under Visual Studio. The installation of Visual Studio Code under Microsoft Windows is also quite simple. To begin, you'll need to go to the Visual Studio Code website and download the latest version of VS Code for Windows. Once it's been downloaded, go into your download directory and click on the file to start the installation process. You will need to accept the license agreement, accept or change the path for the installation, and accept or change the Start Menu folder item. It's very important to make certain that Add to Path has been checked off on the Select Additional Tasks menu. You can also select some of the other tasks as well if you wish. Now you're ready to install, and the installation will proceed. Once the installation is done, you can click the Finish button to launch Visual Studio Code. But we're not done yet. You're also going to need to install a version of Python for Windows. Go to the python.org website and download the latest version of Python for Windows. You might note that on some computers you will need to use a 32 as opposed to a 64-bit version of Python, and that's fine. That'll work with PlatformIO just as well. Make certain to check Add Python to Path at the bottom. This is very important. Then click Install Now and allow changes to your device to be made. The installation will then proceed. Once Python has been installed, you can open up Visual Studio Code, and we can begin to install PlatformIO. Once you've installed Visual Studio, you'll need to install PlatformIO, and the procedure is the same no matter what your operating system is. I'm showing it here for Windows, but you'll do the exact same thing for Linux or OS X. Go to the Extensions button and open it up, and then start searching for PlatformIO. You'll see the PlatformIO IDE. Click the Install button to begin the installation. The installation of PlatformIO can take a bit of time as it has to download several components. Be patient and don't do anything else in Visual Studio Code while PlatformIO is being installed. You can observe the progress of your PlatformIO installation in the bottom corner of the screen. Once PlatformIO has been installed, you will need to restart Visual Studio Code. So close VS Code and open it up again. Every time you open Visual Studio Code, it needs to activate its extensions, and it will check to make certain that you have the latest version of PlatformIO. Once it's completed that, you will notice the PlatformIO icon on the left-hand side. You can click on this to open PlatformIO. You can also use the little Home button at the bottom to do the same thing. And this completes the installation of PlatformIO under Visual Studio Code. Okay, so now that we've got PlatformIO set up, let's start to work with it. And instead of just using an Arduino for our experiments, I'm going to use 3 different microcontrollers to show you how we can move easily from board to board with PlatformIO. So I'll be using an Arduino Uno, an ESP32, and a Seeeduino XIAO for our basic demonstrations of the use of PlatformIO. So we're on the Visual Studio Code home screen, and we're going to begin using PlatformIO, and we can call it PlatformIO with this little Home button right at the bottom of the screen. And this brings up the main page for PlatformIO, the home page. Now we'll take a look at this in a moment, but first of all, let's take a look at some of these icons down the side here. Now projects will indicate all the projects that we've worked on. Since we're just getting started, we have no projects in here. Everything we build with PlatformIO is called a project. Inspect allows us to inspect the individual projects, determine what environment they're running in, inspect the amount of memory they're running, and also check the code in them. Libraries, of course, is a method of managing the different libraries in PlatformIO, and we'll be talking about libraries a little later on in this video. Boards indicates all the different boards that PlatformIO is capable of supporting, and there are over 900 of these boards right now, so there are an extensive number of microcontrollers we can use with this. Platforms is something that probably will not be relevant to us. It allows us to work with different platforms, including the Atmel AVR, which is the main one that we're going to be working with right now, and work with them on different versions of PlatformIO running under different IDEs. Devices indicates the devices that are attached to our computer, and you can see I have one here right now because I have an Arduino Uno attached to one of my USB ports, and it's already determined this, so I don't need to manually put that in. That's a very nice feature. Let's go back to the home page right now, and let's start a new project. And we're going to give our project a name. And I called it Arduino Blink Test, so you can sort of guess what I'm going to do here. Now we can select the board that we've got attached to here. Now there's 937 available, and we could scroll through the list, but it's much easier just to start typing. And then Arduino Uno has been found over here. The framework is the Arduino framework. And we'll hit finish. Now this can take a few moments when you're first starting PlatformIO because it needs to load a number of files the first time. And it has now loaded it. And you'll notice over here we now have Arduino Blink Test on the side, including a number of different directories. Now we want to go to the SRC or source directory, and we'll see a file called main.cpp, and this is one way that PlatformIO differs from the Arduino IDE. In the Arduino IDE, our files have a .ino extension. In PlatformIO, we use the .cpp extension, and that is for C++, the language we are programming in. And our primary file is always by default named main.cpp. So let's click on it to open it in the editor. And here's our file in the editor. Now one thing you'll notice is that we have a blank file, the same that we do when we start off an Arduino blank file, with one major difference, and it's this include statement at the top. We need to include the Arduino library, and this is true for all Arduino code that we are going to write. And so let's paste in some code that we can use over here. And here is basically our blink sketch. And the blink sketch, of course, really doesn't need much of an introduction. In the setup, we just set our pin as an output, and we're going to be using the built-in LED, so we use the constant LED built-in, which will work with an Arduino Uno, but not all boards. And then in the loop, we set the LED high, and we delay for a second, then we set it low and delay for a second. I'm sure you're familiar with the blink sketch. Now when we want to compile this, we can hit this little checkbox at the bottom over here, and the compilation happens and it says it's successful, the code is good, and right next to it we have an arrow, and we can use that to load that to our Arduino. And success, it has been loaded to the Arduino, and if we look at our Arduino, we can see indeed that the built-in LED is flashing, which is really quite phenomenal, of course. Now let's go and repeat this experiment, but let's use a different board. So I've replaced the Arduino Uno with an ESP32 board, and I'm back in PlatformIO on the home screen, and you can always get to the home screen again with that button at the bottom over here. Now, you'll notice that in my recent projects, you'll see the Arduino Uno, and you'll also see it on the Explorer pane on the side of the screen. So I can still jump back to that project, and I still have the editor for that open up over here as well. So you can work on more than one project simultaneously with PlatformIO. Now I'm going to start a new project for my ESP32, so I'll click New Project, and we'll give it a name. And we'll need to find a board, and of course I'm looking for an ESP32 board. And there are a number of them to choose from. Now there's one down here, Expressive ESP32 Dev Module, that'll work for many ESP32 boards, and I'm assuming it's going to work for mine. I'll hit Finish, and it needs to build up the project first. And then I've got my ESP32 board down over here, so I can go into Source and open the main CPP, and this is the main file for the ESP32 board. Now you'll notice it starts off the same, and you'll also notice that despite being an ESP32, it includes the Arduino library, because we're still using the Arduino framework in order to build our project. So I'm going to paste our project into here, and it's the exact same Blink sketch. And so now I'm going to go and hit the build button down over here to compile it. And you'll notice that it failed. I got an error, and if you can see that, I'm sorry, the text is rather small, it tells me that LED built-in was not declared in this scope. And that is correct, because LED built-in is not a constant that is used on the ESP32 board. Also, it is not on pin 13, so I'll unremark this statement over here, and I'll change it to another pin number, and we'll give that another try. And that was successful. So now let's upload that to our ESP32, and again you'll notice that I didn't have to tell it what port number that the device was on. And it was successful. And if you look, you can see my ESP32 is blinking away, and the blink sketch has worked. So now I've replaced my processor with another one, this time a Seeeduino XIAO, and we're going to go and basically do the same thing with the XIAO, but we'll spruce it up a little bit because the blink test is getting a bit boring. But first of all, I don't see my PlatformIO main menu, so what am I going to do? Well, over here on the side, you will see an icon for PlatformIO, and if I click this, I get quick access. You'll notice it down over here, and if I click on Open, I can get to that same main screen. So I'll click New Project. And I'll give it a name, and I'll select the board. I'm going to type in XIAO. And I have the Seeeduino XIAO over here. And again, it's using the Arduino framework. So I'm going to hit Finish. Now, when you first do this, you'll probably have to wait a moment while it loads some libraries, because my editor has seen the XIAO before it's already done that. So I can see my Seeeduino XIAO blink test down over here. I can hit the SRC and open main.cpp. And here's main.cpp, and again it's using the Arduino framework, so that needs to be here. And I'll paste my blink code into it. Now let's spruce up this code a little bit, because blinking an LED is getting to be kind of boring. So what we're going to do is we're going to add the serial monitor in. So first I need to do that in setup. I'm going to start typing, and you'll notice that it started suggesting things, and here is serial. So serial dot, and it also suggests begin. And I know I need a bracket over here, and it's telling me what I need in it. So this is a wonderful feature of PlatformIO. It'll actually show you what it needs, and it helps you write better code, and it stops you from making very common errors. I'll give it a baud rate. And I know I need a semicolon at the end. And so now let's actually print something. So we'll go, after we set the LED high, it knows I need serial dot, and I can go down and find print, and I want to do a print lin because I want it to also have a carriage return at the end. And then I know I need a bracket, and it knows I need something to print, and I'm going to do double quotes, and you'll notice it put 2 double quotes there, and it put my cursor in the middle, which is again very handy. And I'm just going to print out the status of it, which is high. Incidentally, on the Seeeduino XIAO, high turns the LED off and low turns it on. It's backwards from the other ones. And I'll take that line, and I'll just copy that. And I'll paste it down over here and change the text on that to that there. Okay, so now that should print out to the serial monitor. So first of all, let's do a build, make sure I'm okay. And it's successful. And so let's load that up to our Arduino, our Seeeduino XIAO. And you'll notice that the XIAO is indeed blinking its LED, which is what we would hope it would do. However, I also used a serial monitor, and I'm not seeing that. Well, if you go to the bottom taskbar, you will see a little icon that looks like a plug, and that's the serial monitor, and it'll change your terminal to a serial monitor. And so here we are, low, high, low, high. We are seeing the output of the serial monitor down here. So this illustrates both the autocomplete and the suggest in PlatformIO, as well as the use of the serial monitor. And so you've probably noticed that we're no longer in PlatformIO. We are back in the Arduino IDE. And the reason for this is I want to show you a couple of differences between the Arduino IDE and PlatformIO in the way that they process code. And I've created another sketch. Now this is sort of a better blink. I'm calling it blink with function. And what I've done is I've moved the blink utility into its own function. So the sketch is pretty simple. We define our LED and we're going to call it LED pin, and of course it's on pin 13 because it's the built-in one. And then in the setup we're going to initialize that as an output. All of that pretty straightforward. Now before we look at the loop, let's go and take a look at the function I've created, and I've called my function blink LED, and it has two input parameters, both of them integers. One of them is the LED that we're actually going to be blinking, so in other words the pin number, and the other one is the delay time in milliseconds. And so in the function you can see everything's pretty simple. It's really the blink sketch all over again. We're going to do a digital write to the LED, and we're going to send it high, and we're going to delay it by the delay time we specify up here, and then we're going to go through and do the same thing by setting it low and going through the delay time. So now back into our loop, and we're going to make this a little more interesting because it's getting a bit boring just watching an LED flash at a steady rate. So we're going to first of all blink it 6 times for half-second intervals. So I put in a for loop over here, and within the for loop I've got my function blink LED. I send it the parameter of the LED, which I've defined as LED pin, and 500, which is 500 milliseconds or half a second. And then after I finish doing that, I'm going to do the same thing, but we're going to do it 3 times for a 2-second interval. So again I have another for loop over here, and I call my function blink LED, and this time I pass it 2000 because that'll be 2000 milliseconds or 2 seconds. So again, it's a pretty simple sketch. Let's go and upload it to the Arduino and make certain that it works. And we're done uploading. And there we go. Blinking quickly. And then a slow 2-second blink. And then the loop repeats itself. So this works properly. Now what I'm going to do is I'm going to clear that out of the Arduino, and this is an easy way to do it. Just open a new file, a blank file, and upload that to your Arduino. And you'll notice it stopped blinking because I've basically cleared out the code. So now we can try this out on PlatformIO and see if we get the same results. And we're back in PlatformIO, and I've created a new project for my blink with function sketch, and it is identical to the one I used in the Arduino IDE, with the exception of the one include up here for the Arduino library, which is required in PlatformIO. So it should simply be a matter of building this and then uploading it. So let's just go and do a build. And it failed. Something was wrong with this build over here. Now, what could the problem have been? And the problem is over here is that it says blink LED was not defined in this scope. In other words, my function blink LED has not been defined. It ran across it over here and it said, what's blink LED? I don't know what that is. Well, we can see obviously that I've created a function called blink LED, but the problem here is the sequence I've created it in. I put it after the loop. And in PlatformIO, you need to define all of your functions before you actually use them in the code. Now, in defense of PlatformIO, this is pretty common for just about every IDE. The Arduino IDE is a bit of an exception in that it will allow you to define functions after you've used it, and it'll figure out what you want to do. But in PlatformIO, you have to be a little stricter with the way you write code. So this is actually forcing me to write better code. So I'm just going to go here and cut that. And I'm going to put that right before my setup over here. And now let's see if that will compile. And that's successful. And I can upload that successfully to the Arduino. And as you can see, the Arduino is now doing its fancy blink function, its fast one, and now its slow one. And so that's something to be learned, is that you need to define all of your functions in PlatformIO before you actually use them. Now, one of the most important things that we need to be able to do when we're coding for microcontrollers is to manage libraries. Libraries are additional pieces of code that are used when we're using different I/O devices. So, for example, if we get a special sensor, we can find a library to use to add additional functions to our code to work with that sensor. Now, both the Arduino IDE and PlatformIO have a library manager, and both of them have access to thousands and thousands of libraries. But the way that we handle libraries in PlatformIO is a bit different than the way it's done in the Arduino IDE. And as you'll see, it does have a few advantages over the method we used with the Arduino IDE. So let's go and take a look at how we do that, and then we'll build a little project that is going to require a couple of libraries, and we'll see how we use it with PlatformIO. The PlatformIO registry has over 10,000 libraries to choose from. It includes libraries from sources like Git, HG, and SVN Subversion. It has a very advanced library search feature that allows you to search by the library name, by the file name, or the name of the component that the library supports. Most of the libraries are very well documented, and they include example code. When using the Arduino framework, you have access to all of the Arduino built-in libraries. PlatformIO libraries work a bit differently than libraries in the Arduino IDE. Here we have the Arduino IDE and 4 sketches. We'll import a library into one of our sketches. That library then becomes available to every one of our sketches. If we update our library to a newer version, all 4 sketches will obtain the newer version. This can sometimes cause problems with sketches that were dependent upon the older version. It also creates issues if you import a library that has the same name as the current library, and this is a situation that sometimes occurs. Now with PlatformIO, you do have the option of importing libraries in the same way the Arduino does, allowing them to be available for all of your projects. However, you can also import libraries just for specific projects. In this case, we have a library being imported for project number 1 and project number 3. Now we've updated the library for project number 1, and we've also added that library to project number 4. Note that project number 3 we haven't chosen to update, and it remains at the old version of the library. By having libraries on a per-project basis, you have a lot more flexibility and control with PlatformIO. The parameters for your PlatformIO project, including the libraries that it depends upon, are stored in a file called platformio.ini, and we'll be taking a look at that file in a few moments. So now we'll build a project to illustrate how to use PlatformIO libraries. Now for our library demonstration project, you're going to require an Arduino Uno, a PCA 9685 16-channel servo motor controller, a liquid crystal display with an I2C backpack on it, a 5 to 6 volt power supply capable of powering a couple of servo motors, 2 potentiometers. I used a couple of 10K linear taper pots, and a couple of servo motors. I used two SG90s. We'll begin by connecting the 5-volt output of the Arduino to one side of each of the pots. The Arduino's ground output is connected to the other side of the potentiometers. We'll connect analog pin A0 to the wiper of one of the pots, and analog pin A1 to the wiper of the second one. We'll connect the ground to the ground connection on the I2C backpack for the LCD display. We'll connect 5 volts to the VCC connection on the same display. Analog pin A4 is connected to the SDA connection on the I2C backpack on the display, and analog pin A5 is connected to the SCL connection. We'll also connect analog pin A4 to the SDA connection on the PCA9685, and pin A5 will be connected to the SCL connection. We'll connect 5 volts to the VCC connection on the PCA9685. Notice that we're using the VCC connection and not the V+ connection, which is a connection for power to the servo motors. And the ground will be connected to the ground connection on the servo module. We'll connect the 5 to 6 volt DC power supply to the servo power input on the PCA9685. Please note the polarity here. And finally, we'll plug our 2 servo motors in to ports numbers 0 and 1 on the PCA9685. And this completes the wiring of our test circuit. Now let's go and take a look at the code. So I'm back in PlatformIO, and I've already created a new project that I am calling Servo Motor Demo. And I've got the main.cpp file, and I've entered my code into it. And I want to show you a few things about using the code editor. Now there's a feature on the side here which is actually a feature of Visual Studio Code. And this is a minified version of my code. Now my code is fairly long, but I can skip the different parts of the code just by going up and down this. So this makes it a little easier to navigate. Now you'll notice I've got a couple of red lines up over here, and the red lines are the equivalent of these squiggly lines you see under these two statements. And these are the statements that call up my libraries. And if I highlight these, you'll see what the problem it is. It says I cannot open source file liquid crystal, and that is because I haven't installed the library. And the same is true for this Adafruit PWM library over here. You'll notice that the include on the Arduino library doesn't have a squiggle because it's there, nor is there an include on the wire library because that is a built-in library of the Arduino, and so that is included in every PlatformIO program that uses the Arduino AVR. So what I need to do is I need to install this library. Let's go and install this one first, this liquid crystal one. I'm going to copy its name right now, and then go into the PlatformIO home and go into libraries, and I'm going to paste the name into the search box. And I'll hit the search button. And there's my library down over here, and I'm going to click on it, and you'll notice what I get with the library. I get all of this example code over here that shows me how to use the library. I also get installation instructions over here. I get the headers for the library, and I get any change logs that happen to show all the different releases of the library. So let's go and add this library into our project. I'll click the Add to Project button, and I'll select the project, and I'm going to use the Servo Motor Demo, which happens to be the first one on the list because it's my most recent project. And I'll click the Add button. And it congratulates me I've added the library to my project. Now I have a second library, and that was the Adafruit PWM servo driver. Rather than copy its name, I'm just going to do it freeform. Adafruit PWM servo should be enough. And there it is over here. And again, I can add that one to my project as well. Select the project and add the library. And again, I'm congratulated because it's there. Now if I go into main.cpp, you'll see the squiggly lines are gone and the red lines are gone and my minified because I've got them there. Now, if we go into PlatformIO, you'll notice that when you highlight specific things, you will get information. So for example, over here, if I highlight, it tells you exactly what this is, a class that stores a state and functions for interacting with the PCA9685 PWM chip. It also memorizes all the variables and constants that you've made. So for example, over here in this statement, I'm using two constants I defined, min pulse width and max pulse width. If I highlight them, it'll tell me what the values are, 650 for this one and 2350 for this particular one. If I go down into something like this one over here, set PWM frequency, it tells me exactly what it is. Sets the PWM frequency for the entire chip up to 1.6 kilohertz. And if I highlight frequency, I'll see I'm setting it to 50 hertz. And so you can go through this for pretty well everything in your code and learn what your code does. And this is fantastic if you're taking some code you haven't written yourself and you want to modify it and you want to know what these things do, or if you have a long code and you'd just like to know what the value of a particular variable is. Now another feature, and I'm going to go down over here, is when you have things like ifs or other loops and things inside your code, you'll notice there's a line here. You may have some problems seeing it, but this shows me what the extent of this if statement is. It goes from here to here. And if I've got nested statements with other if statements or for next statements within it, I'll see lines for those as well. And you can tell where everything stops and starts. You can also highlight the opening bracket, and that'll highlight all of this, and it highlights the close bracket. Now mind you, highlighting the opening and close bracket is also a feature in the Arduino IDE. Now let's go up to the top and just quickly see what this code actually does. Now we've included all of these libraries at the top, and we're going to define the I2C address for our display, which we do over here. Now there's another common address, hexadecimal 27, that some of these displays use, so you may need to change that for yours. And then we define an LCD object over here at that address. We define a couple of parameters to the PWM object. We define the PWM object over here, and then we have a couple of things that define what our inputs are. These are two integers over here, control 0 and control 1 for the pots on A0 and A1 respectively. We have integers that represent our two motors, motors 0 and 1, and then a couple of integers that represent the degree that the motor is needed to be positioned at. So I have degree for motor 0 and degree for motor 1 over here. I also define the previous reading of degrees, and the reason I do that will become apparent in a few moments, and that's also lines in with this Boolean I defined to say whether I should update my display or not. Then I create two functions. The first function doesn't have any output, so it's just a void, and it's move motor degree. And I have two parameters I put in, the amount of degrees I want to move my motor to, and the motor that I want to move. And then down over here I've defined another function which is get degree, and this one actually produces an integer output. It's not a void. So I input the name of the control that I'm using, either A0 or A1, and it'll output the number of degrees, and it's just using a map statement over here in order to convert it to 0 to 180. Then I go into my setup, and the setup I initialize the pulse width modulator controller, and I set it at the correct frequency. I also set the LCD display up, and I set it for a 16:2 display, which is what I have. I turn on its backlight over here to full intensity. I clear the display, and I print on the display just to start with. And then I set up my serial monitor, and note the baud rate that I'm using for this serial monitor, 19.2. Then I'll go into my loop, and the loop is now very simple. Remember, I've defined my functions before the loop, or else I will get an error in PlatformIO. Here I define the position of servo motor 0. So I get the desired position by doing get degree, the function I wrote earlier that reads the control, and that's the number of degrees I want to move the motor to. Now, I'm only going to move the motor if its position has changed since the last time. The reason I'm doing this is I want to prevent flickering on my LCD display, so I don't want to update the display unless I actually have to. And so if the motor degree is not equal to the previous one, then I'm going to move the motor using my move motor deg function that I wrote earlier. I'll update my display, so I'll set that parameter to a 1 instead of a 0. That's the Boolean I defined earlier, and I can highlight that to tell me what that is. And then I'll update the previous position to this position, so the next time I run around, I know the previous position. I do the same thing for motor number 1. And then I go through and update the display only if it's required. If update display as indeed have a value of 1, then I'll clear the display, and I'm going to print on the display the values of the motor positions over here. And then at the end, I'm just going to print out to my serial monitor, which prints out the positions of both of the motors. And then I'm going to reset that update display variable to 0 before I run through the loop again. And I'm adding a very short delay to this just to keep the motors from chattering. And so that's my sketch. What I'm going to do is compile it right now, or build it. And it builds successfully. And I will update that to my Arduino, and we will watch it work. And so here's my test setup over here. As you can see, I've got my liquid crystal display and the I2C backpack. Now I've mounted the backpack on the front of my display, which is actually backwards. It should really be on the back of the display. But I keep it over here because this is just my little experimenter's display, and I find it a lot easier if I can get at the backpack on the top. Now here, of course, are my two servo motors, and here's the PCA 9685 I'm using to drive it on this little solderless breadboard. You'll also see the two potentiometers that I'm using in order to control the motors. Now for my power for the motors, I'm just using these 4 AA cells over here. So I've got a 6-volt battery over here to power it, and that's a good power source for servos. And of course you can see my Arduino Uno over here. Now I've loaded the code, so all we need to do is watch it work, and I'll twist it and I can move the servos. And you see the two servos move. And it's written on the display. So this is pretty well exactly what we were hoping that it would do. So now let's go back into PlatformIO, because as you'll recall, I'm also using my serial monitor. So let's go down over here and put on the serial monitor and see what we get. And what we get is a bunch of gobbledygook at the bottom. And the reason, of course, for getting all of this gobbledygook is because we have set the serial to 19200, and the serial monitor is still trying to work at 9600. So we need to be able to correct that, and in order to do that, it's time to take a look at the platformio.ini file. Now, as I mentioned in the explainer earlier, the platformio.ini file contains all of the parameters specific to the project. Now, before we do that, this is getting a bit annoying at the bottom, so let's stop the serial monitor, which you can do with a Control-C, and then if you hit Enter, you'll be back into the terminal mode. Now, let's go and take a look at platformio.ini. So we'll open up the file over here, and this is the configuration file for our particular project. And you'll notice a few things about it. First of all, it tells you what the environment is. Over here, it's the Uno. The platform is the Atmel AVR. The board is the Uno. The framework is Arduino. Then it goes and shows you the two library dependencies that we've got. So here's the liquid crystal library we added, and here's the Adafruit library. Now, you can actually put these in manually rather than going through the library installer like I showed you earlier, but I find the installer a bit easier. Now, the next thing we need to do is actually tell it that we want to use 19.2 instead of 9600. So we do it like this. Monitor speed, and then it equals 19200. And then I'm going to do a Control-S to save everything. And we'll go back into main.cpp, and let's pull our serial monitor up again. And now, as you can see, the serial monitor is showing what we want. And if I move my controls, I'll get the readings the same as I had on the liquid crystal. And so we've now set it on this particular project to work at 19200 using the platformio.ini file. Alright, well that brings us to the end of this video about PlatformIO, but it's certainly not the last time you're going to see PlatformIO here in the DroneBot workshop. Going forward, I'm going to be using a mixture of both PlatformIO and the Arduino IDE. For our simpler projects, you'll see the Arduino IDE, but for the more advanced ones, or the ones that use new microcontrollers, I'll be using PlatformIO, because as you've seen, PlatformIO has a lot of advantages over the Arduino IDE in terms of writing code. Now, if you want some more information about PlatformIO, you can check out the article on the DroneBotWorkshop.com website, and you'll find a link below the video to that article. And in that article, you'll also find links out to all sorts of resources for both PlatformIO and for Visual Studio Code. Now, if you want to discuss the contents of this video, you can certainly leave some comments in the YouTube video. I love seeing your comments, but I don't always have time to answer them. And a great place to get a dialogue going is on the DroneBot Workshop forum. And I want to talk to you about a new section that I've just added to the forum this week. And that section is a section to discuss all of my videos. This was something that was recommended by a forum member, and I thought it was a great idea. So I've broken them down year by year, and there is a post for every single video, and you can go into there and discuss this video or a video I did 2 years ago, and that discussion will come right up to the top and other people can get in on it. And you can of course add code samples, talk about problems you might be having with projects based upon those videos, and do a lot more than you could just in the comments for YouTube. Now, if you're not a member of the forum, it's free to join. Just follow the link below and get the details for doing that. Another thing that is free is my newsletter, and my newsletter is not a sales letter by any means. It's just a way of letting you know what's going on here in the workshop, and you'll find a link to the newsletter right below this video. And finally, if you haven't subscribed yet to the channel, please do. About 70% of the people who watch these videos are still not subscribers, and I'd really love to have you as a subscriber. So all you need to do is hit that subscribe button and then hit the bell notification so that you'll be notified every time I make a new video. Now, some folks have told me they've hit the bell and they're still not notified, and in that case that is probably because in your settings for YouTube you've blocked notifications, so make sure you haven't done that. So until the next time that we meet, take good care of yourselves, stay safe, and we will see you soon here in the DroneBot Workshop. Goodbye for now.